welcome to the beginning of our Behavior of Matter unit. We're going to start by just simply reviewing states of matter. Make sure that I'm recording okay. Yep. We're going to start by just reviewing simple states of matter, definitions we've talked about before, and we're going to go a little bit more in depth with the states of matter in this unit. The three phases of matter that we discuss are solids, liquids, and gases. In a solid, matter is held together in a rigid form. Solids have definite volume and shape, and there are strong forces between the particles that hold the molecules together. Solids are said to have a crystalline arrangement, which is a very orderly arrangement of molecules. When we want to actually write that something is a solid, we just use this little S after it. So if you want to show solid salt, you put that little S there. A very important concept that we're introducing today that is going to come up in a number of units is the concept of intermolecular forces. Intermolecular forces are a very important idea in chemistry. These are forces between separate particles or between separate molecules. In solid matter, the particles and the molecules are held together with really strong intermolecular forces. So that's why they actually act as a solid, and they're difficult to deform or move or bend or things like that. I do want to make a little difference. We really only talk about intermolecular forces. We do talk about what are called intramolecular forces, but we refer to them as bonds. I do want you to have a really strong understanding for the difference between the two of these. In water, you have an oxygen that is bonded to two hydrogens. This right here is a bond. It is an intramolecular force. It's within a molecule. So to be intra means you're within. Inter, if you were to get on an interstate highway is between separate states. So what we actually identify here as being an intermolecular force is an attraction that occurs between these separate molecules right here. So this is a force between separate molecules. And it's very, very important that we differentiate this from a bond. A bond is occurring within a molecule, whereas this is between separate molecules. Liquid phases. The liquid phase is not quite so rigid. Particles have some mobility and the ability to flow past one another or flow. The sample of liquid does not have a definite shape, but they do have a definite volume. So if you take, for example, 40 milliliters of water, and you have it in one container and you pour it into a different container, it will, to a certain extent, take the shape of that container, but it's not going to change its volume. So it won't necessarily fill any container you put it on, which is something that a gas will do. However, as you well know, if you knock over a container with liquid in it, it will spill, it will move, it does not have definite shape, whereas a solid would stay locked into place. So this is a little diagram kind of showing that simple comparison between that locked in, a little bit more space, and then you have your gas really spread out. Liquids have moderate intermolecular forces, and we use this little L. Very often you'll see it look more like a little cursive L. We want to indicate that something is a liquid. The gaseous state, molecules are all over the place. We indicate this with the little G right here. Gases have the weakest intermolecular forces. They do not have a definite shape. They do not have a definite volume. They will fill any container you put them in. If that container doesn't have a top, they will just leave the container. Properties like pressure, volume, and temperature have a relationship in a sample of a gas. You can actually, change one of these and it will have an effect on the other one. As I mentioned, they fill any container they're in. A closely related term we're going to use a little bit is the term vapor. This is the gaseous phase of a substance that is usually a liquid. When I think about a vapor, if you think about boiling some water, right above the surface of the water, you have that kind of damp feeling steam. That's really what a vapor is, but it has gaseous behavior. Type of mixture to note, we talked before about aqueous solutions. remembering that water is the solvent. For example, salt water is an aqueous solution of salt and water. So we show that with that little AQ. We talk about these ding, ding, dings all the time. So just make sure that you're very clear on the fact that when we have just the S or the L or the G, these are all substances. This is indicating just solid salt, just liquid salt, just liquid water, just liquid water, just oxygen gas. However, with any of the ones that have AQ with them, NaCl, CaCl2, once you see this AQ right here, it means in each of these, for example, this is actually NaCl and water. This is CaCl2 and water. So therefore, these are not substances, they are mixtures. I know we beat that point to death, but it is a very important thing to keep in mind. And that is where we are going to stop for today.